right, thank you for joining us for our webinar today, Testing the Internet of Things, Making IoT Work. I am Kelly Hill. I'm an editor with RCR Wireless News. We are a very well-known news source for wireless communications, and we try to be first with carrier, distributor, network, handset, and mobile content news, as well as doing things like our webinar today. So your panelists for today, I'd like to introduce all of them. Obviously, I'll be your moderator for this discussion. We're also joined by Mariano Kimbara, who's an industry analyst with the measurement and instrumentation practice at Frost & Sullivan. We have George Japak, managing director for ICSA Labs, which is an independent division of Verizon. We have Michael Starsinic, member of the technical staff at InterDigital Communications. And we have Brad Robbins, president of LightPoint. And we're also joined by Vikram Sexina, who is from the office of the CTO with NetScout. So we are going to be getting a broad range of views today on this topic. Just to mention a few pieces of recent IoT news that are relevant to this conversation. We had 1M2M recently releasing the latest version of its specification for IoT. Just a couple of days ago, we had Allseen announcing that it was going to be merging its IoT standards work with the Open Connectivity Forum, and they're going to be operating under the OCF name now. Comcast just launched a new IoT venture trial, a Machine Q. They're going to be relying on LoRa technology for that. And then we've also had IoT security in the news in terms of the Mirai IoT botnet attack. There was a large attack on Krebs security, denial of service attack, and this was achieved by utilizing IoT devices. So with that, we do have available on the rcrwireless.com website our IoT special report, which digs into some of the aspects we're going to be discussing here today. A few of the points from this report. We do have new form factors in IoT posing a physical challenge for testing in terms of connections, OTA versus cabled testing. Cost of test is definitely one of the challenges for IoT adoption and does influence the business case. So some of the major influences that factor into IoT testing include RF design, the choice of module versus chipset, the choice of wireless technology, standards proliferation in the IoT space, as well as the amount, type, and visibility of data communications with the networks. And that is, also gets into things like impacts on battery life and a whole lot of other aspects of IoT. So that's available for download. That's a free download on rcrwireless.com. And right now, I want to hand it over to Mariano Kimbara from Frost & Sullivan to talk to us about some of the market factors that are impacting testing for IoT.
Thank you, Kelly. Good afternoon, everybody, and a very warm welcome for everyone for joining us for this presentation today. For my part of the presentation, I would like to discuss a market strategic vision for the test equipment market. We recently published this year a study report called New Competition for the Global Test and Measurement Market in IoT Wireless. So we are very happy to share some of our very initial findings of this research with our participants today. Next slide. Next slide. So the use of wireless has risen exponentially with increasing number of connected devices with a number of heterogeneous wireless technology networks. For the purpose of our research, we have categorized this into 4 main classes, including the wireless personal area network, the wireless local area network, the neighborhood area network, and the wide area network. We have covered signal generators, spectrum, signal analyzers, one-box testers, protocol analyzers for modular, benchtop, and handheld instruments. Today, more than 60 legacy technologies and emerging RF formats for IoT applications are used. In particular, Zigbee and Thread are emerging technologies where Wi-Fi, Bluetooth, and cellular have been used extensively for some time. In some niche applications, such as for personal area network for wearables and local area network for home automation, Bluetooth is widely used. For proximity wireless technology network, NFC is widely accepted. Zigbee and Thread are primary choices when it comes for low power networks in smart homes and smart energy applications. When we look at the largest segment of the wireless communication, the market is still focused under the 6 gigahertz, and most standards do not require more than 100 megahertz of signal analyst bandwidth. However, when we look at the emerging 5G, this is expected to be deployed in the uncrowded 60 to 80 gigahertz millimeter wave bands, and we expect modulation bandwidth up to 2 gigahertz. In terms of the technologies under the 6 gigahertz frequency ranges that are driving demand, significant activity is seen in the LTE unlicensed development for wireless networks that use unlicensed spectrum. More specifically, now significant focus falls on spectrum allocation in the 2.4 gigahertz frequency range for commercial applications. Technical enhancement will support high volume production environment testing with the capability to obtain ultra wideband signals in a single trial and to get data from several integrated wireless devices in parallel for faster multi-site test outlines. Next slide, please. A brief description of the current state of the test equipment market is described in this slide. The global test and measurement market for Internet of Things wireless technologies exhibit increased annual growth in revenue. This market reached 168.6 million in base year 2015. We foresee sustained double-digit growth picking up to 11.6% compound annual growth rate in the forecast period from 2015 to 2020. The consumer electronics segment in particular held the largest market share at 39.2%, followed by industrial automation and smart cars. The bulk of the market is focused on wireless personal area networks with a number of Bluetooth deals in low bandwidth and low battery life for some key applications, including mobile devices, smart watches, fitness devices, healthcare monitoring, and home entertainment. Next slide. In this slide, we want to show some of the existing opportunities from an end user vertical perspective. For consumer applications, the opportunities for testing are high, coming from low power devices in emerging products, such as mentioned before in smartwatches and home entertainment. For consumers, increasing demand for testing applications are focused on Bluetooth and Wi-Fi, and we expect sustained revenues coming from this segment. Industrial automation, advancing services, intelligent monitoring, and process automation are expected to see a strong surge in convergence basic technologies, increasing demand for testing application we have seen focusing on Zigbee. Smart cars. Today, 20% or less of vehicles are connected vehicles. This will increase exponentially in the next 5 years. So we have seen more opportunities coming from Bluetooth and Wi-Fi for small data transmission. We have seen more opportunities focused on 10 megahertz data bandwidth, test opportunities supporting, for example, 5.9 gigahertz. Next slide. Yes, next slide. So here we have listed some of the specific end user requirements for testing equipment for IoT. And when it comes for some of the key end user requirements, of course, speed and cost of test is the #1 requirement. Focus will center on enhancing the speed rate to effectively reduce the cost of testing and the time to market an IoT device. The manufacturing environment is focused not only in the cost of test equipment, but also the maintenance cost, calibration cost, power cost, and space cost. If OEMs can enhance the speed of their current testers, of course, these factors will be reduced as well. Here also we have some of the selected quotes we have from several end users. One of the quotes to share, for example, can I tailor the test equipment in order to make the measurement that I need? With a PC, you can add more RAM and hard drive over time. You cannot really do that with conventional test equipment. We need an instrument that follows this kind of philosophy. So therefore, second requirement, upgradable and customized test solution is a second key requirement in the market. The need is increasing to provide test systems that are modular, tailored, and upgradable in supporting concurrent tests for a wide range of wireless technology for multi-standard IoT devices. Third key requirement we have seen is integrated test capabilities. Today, using multiple equipment to test different technologies is proving to be an expensive proposition. Therefore, there are increasing requirements for integrated test instruments such as vector signal generators and signal analyzers capabilities, all in one box testers. Next slide, please. So what are some of the top transformational shifts and opportunities from a test equipment perspective for IoT in the coming years? Number one, of course, software and modular form factor. An open architecture will provide the flexibility required to redefine the test platform and support complex needs in the IoT wireless market. Users, of course, will have the opportunity to buy a wireless module rather than needing new custom RF test equipment to support new wireless technologies. Secondly, hybrid model and a combination of instruments. As I said before, a trend has begun in utilizing a combination of instruments. Those combining instruments today are becoming more capable. This is the case, for example, combining a spectrum analyzer and a network analyzer. This kind of hybrid instrument model today can achieve a high level of standardization while providing customer cost and flexibility benefits that significantly simplify the test strategies and redefine the total test and measurement for IoT wireless. Third, and very important, we have seen the focus on providing a comprehensive package of services. We believe test systems could evolve in the future, potentially beyond just being hard assets. Therefore, there is a need for increasing flexibility in business models with enhanced kind of service options. For example, cloud-based licenses, fee-based models consisting of pay-per-use, licensing and subscription models like software as a service. Handheld portable equipment, there is a potential for increasing adoption of handheld equipment due to its low capital cost and minimal maintenance requirements compared to other form factors. And of course, traditional benchtop. Demand remains strong for benchtop instruments. However, a key requirement from users involve spending minimal time learning a new interface. Next slide.
Okay.
Next slide.
Okay,
so
go ahead.
here are the last thoughts. So we anticipate growth in new testing scenarios and capabilities required where clients are looking to increase modularity, reprogrammability, and PC control due to a software-defined radio being used more and more for wireless devices. Secondly, new opportunities will come from the increasing flexibility options and being able to measure all sorts of different wireless standards in all the stages of the product life cycle, of course, including R&D, field testing, monitoring, deploying, and manufacturing. Lastly, the future trend is heading toward a software-defining architecture and structure-based rather than a purely hardware-based system. So the wireless industry will require every test and measurement vendor to have a software price position for wireless tests. There is an increasing need for higher modularity, customization, and a software to support cost-effective upgrades and rapid maintenance.
Okay.
So,
go ahead.
No, so with that, I conclude my part of the presentation.
Okay, great. George, let's go ahead and go on to you from ICSA Labs.
Well, thank you. This is George Japak, and as part of the introduction, I manage the ICSA Labs that operates as an independent testing and certification body within Verizon. And What I'll do right now is give you a little bit of an overview and perspective of IoT and security. And next slide. So just in the way of a little bit of an introduction for those that aren't familiar with us is we've been around since 1989 and have been testing and certifying information security related products and doing testing and certification for over 25 years. So in the age of the World Wide Web, that is pretty much ancient, and it speaks to the amount of experience we have in this area. And our business is broken down into the areas that you can see. We are also an ISO accredited organization around quality, as well as proficiency and competency, not only as it relates to the testing that we develop criteria and standards around, but on a couple other fronts. We are also a government accredited lab for doing certain types of testing, and it's this experience that allows us to be able to go ahead and provide value from a security perspective in the Internet of Things. Next slide. So some of these pictures on here should look a little bit familiar to some of you, and obviously the IoT is making the news from not only a positive perspective, but on some occasions from a negative perspective, and not the least of which is part of what Kelly had talked about from the DDoS attack with the one gentleman's site. And so it presents a real prevalent problem that is not likely to be able to go away soon, and is likely to be able to continue. And the prospects for that, as today, it's literally going to be billions of individual devices out there. There's projections as to how many individual interconnected devices that we as individuals are going to be walking around with. And obviously that has consequences to us as an individual, as you've probably seen things around infusion pumps, et cetera, that can be hacked. And these become a lot more consequential than just losing credit card information. People's lives can be put into danger at the same time. And it just adds that much more emphasis to finding a way to be able to make sure that these are secure, and also try to be able to provide to whether or not it's a consumer or an enterprise a level of confidence that these devices can be purchased and deployed in a secure fashion. And just to be able to further emphasize this, we on occasion do birds of a feather BOFs with groups of people. And in Orlando several weeks ago, we got in front of several hundred security practitioners and ran through our IoT and what the underlying testing that we're going to be doing. And literally to the person, they all agreed that from their individual and organizational standpoint, it's an area that's in dire need of privacy and security. Next slide. So some of the other challenges that are out there, and I won't dwell on any one of these, but the lack of standardization. There's a lot of different technologies and means by which to be able to facilitate communication and enable such things within these devices. And a lot of that not only is on the areas of communication, but also security, et cetera, and that lack of standardization manifests itself in a couple different ways. One of the most obvious is the interoperability, or the ability of interoperability of these individual devices, and part of that is also fed by the disparate number of different types of devices out there, which once again, I mean, you can only envision what it is that the quote-unquote Internet of Things is going to touch upon. It's pretty much endless at this point in time. And starting with whether or not the application, the individual device, or all the way down through and including, in some cases, the physical deployment of these, security and privacy is an afterthought, which is not necessarily a good thing. And then the other part of it is device support. In the past, especially on some of the consumer side of things, some of this technology was considered to be like, hey, we'll come out with a new one, and you'll just replace that with another one. Well, as the market matures, the devices, whether or not at the consumer level, and in particular at the enterprise level and at the industrial level, are going to need a certain level of device support. And part of that has to be able to come in the way of when you do have a sector that is going to be subject to people that are going to attempt to be hacking these things. You need the ability to be able to have a dynamic process by which to be able to provide support in the way of updates, fixes, etc. Otherwise, the consequences are going to be pretty dire, and the cost of maintaining them is going to be significantly high as well too. Next slide. So from our perspective, and just as I had indicated, we pretty much break down the Internet of Things into a couple different major categories here. Obviously, the consumer, the commercial side of things, and the industrial. The consumer pretty well speaks for itself, and there's some of the typical things that end up getting deployed. And on the commercial side of things, sometimes it's a little bit of what's in the consumer side of things, like on a connected home, but apply that over to the commercial sector, and the scale, importance, the risks, and everything all change, proportionally. And then when you start getting into the industrial sector, that becomes even a different game, because now you're talking about things that have implications with a number of different things having to be able to do with infrastructure, et cetera. And all of this ends up becoming a new and wonderful attack surface for, depending on who you read, what you believe. There's interesting chess games going on between the countries in terms of attempting to be able to breach and hack different things. So, cyber warfare is very much alive and well. So, and that's going to get nothing but more interesting in a negative way as devices continue to be able to be deployed. Next slide. So, from our perspective, so how do you turn around and you're literally talking about you used to saying hundreds or thousands of different types of devices. I mean, you're talking about billions of devices, but made up of devices that just let your imagination run wild. How do you turn around and start focusing on what is the adequate security? So we just broke them down into a couple different categories: alerting, logging, communication, physical security, authentication, cryptography, and platform security, and gave you some bullet points to be able to take a look at as it relates to each one of these. And for those that know anything about security, you'll say, well, that's foundational, fundamental. Absolutely, but that's the devil's in the detail. Next slide. And then the value of the certification obviously manifests itself in different ways, but people individually as consumers and or companies or those in the industrial space don't necessarily have the same level of skill sets as the developers or as an organization like ourselves. So we have an obligation to try to be able to do that level of due diligence on behalf of them. So whether or not it's a consumer or an enterprise, that they can take a look and purchase these devices with a sense of confidence that these were tested up against a set of publicly available, publicly vetted criteria. Next.
Okay.
The punchline is the fact that it ought not to be rocket science. And again, some of these things are a little bit easier than what they appear, or more difficult than they appear.
Okay. Great. Thank you so much, George. We are going to move on now to Brad Robbins of LightPoint. Brad?
Hey, Kelly, thank you. This is Brad Robbins. I'm president of LightPoint. We're a company that focuses on where the electrons meet the ether, so the wireless part of the wireless standards. And just as George said, IoT shouldn't be rocket science. We think it should be simple. But why don't we go to the next slide? So at the basic level, there are three things that test can really focus on differentiating your products on. And I'm talking about the RF part of the testing, and that's the device's range, the device's throughput, and the device's battery life. And tests can actually enhance performance by calibrating capability in these three areas, and then also checking the quality. So it's really kind of that simple, but also I'll show you why it's that important, and that's really the next slide. Test can help you build a brand. Many people think of test as kind of a manufacturing cost they wish they didn't have. And to the extent they can eliminate it, they should. But when you think about what test can do to build your brand, it's really create a better user experience because the product is a higher quality product that does what you said it would do. And if it's a higher quality product that does what you said it would do, that builds your brand image. And the reason to have a brand is really so you can charge a premium. And so that yields higher ASPs, and that more than funds test cost. The second thing to think about is how cool is your product? If your product is cool, it's typically because there's some new technology that enables a new user experience. And that new user experience then drives the cool factor, which drives market share. So again, that's something that drives revenue, drives top line growth, and helps offset any costs that you have to spend to achieve it. The last thing is time to market. In this fast-paced market, the opportunity to reap large profits if you can reach a world market is large. And so if you can get to the world quickly, that's a much faster profit ramp. So those are three ways that you can help the bottom line through test. Now, you want to do simple, high quality test that's cost effective. But let's go to the next slide. All too often in RF, it's just too complicated. You need, as Mariano was saying, these days of complicated racks of setups, I think are no more because there just aren't enough RF engineers. So the little picture off there to the right, that's somebody wearing a t-shirt with a Smith chart on it. That's too hard. If you think about, I talk to many companies, if you're building suitcases, you're a fabric manufacturer, you know how to glue stuff together. If you add IoT capability to it, all of a sudden now you've become a systems company and you've got to understand RF. If you're a door or bike lock company, you've built something that must work, because if it fails to work, you strand people. If you're building a baby monitor, it must work. Either that or you're going to be running to check on the baby all the time. Or even worse, maybe not alerted to a problem situation. All right, so let's just move to the last slide. And that is, we think testing can be simple. We think you can have a total solution that encapsulates the complexity, solves the problem, and covers all the RF standards. And with that, I'll finish.
All right, excellent. Now we're going to hear from Michael Starsinic of InterDigital, and he's going to be talking about testing applications hosted on IoT devices.
Thank you, Kelly. Could you move to the next slide? So I'm going to be talking a little bit about testing applications that run on 4G cellular IoT platforms. Specifically, I want to talk about some of the challenges that are unique to testing 4G applications compared to testing devices that use protocols such as Z-Wave, Zigbee, 6LoWPAN, etc. Now today, when applications on a UE or a cellular modem talk to a remote server, they traditionally do it in an over-the-top fashion. So by over-the-top, what I mean is the mobile core network is simply a data pipe that allows communication between the applications and the server. In the near future, what we're going to see is that we're going to see tighter integration between the server and the mobile core network. By tighter integration, what I mean is the mobile core network will provide servers with access to APIs that allow them to configure their devices. So they'll be able to configure things like sleep modes, communication schedules, receive notifications when their device is attached to the network. So when it comes to testing, we need to consider not only how the applications on the UE communicate with some remote server over the internet, we also need to consider how the server interacts with the mobile core network. Next slide, please. So this tight integration is something that we needed to consider when testing InterDigital's OneMPower platform. OneMPower is a horizontal services platform that can be scaled to run on large servers, 4G IoT modules, down to devices as small as a Raspberry Pi. This platform offers services and APIs that are compliant with the OneM2M standard and offers a number of additional services beyond what is offered by the standard today. One of these services is called the Service Capability Exposure function. What this function does is it exposes APIs to other applications and services within the platform. And those APIs allow the rest of the platform to access the mobile core network and do things like request a notification if a particular device is attached to the network, configure a sleep schedule, schedule some background data transfer, and so on. Next slide, please.
Oh, excuse me.
So in this example test setup, on the far right, we have a deployment of our OneMPower platform with the SCEF, the Service Capability Exposure function, enabled. On the far left, we have some off-the-shelf LTE modules. And what we do is we connect our Service Capability Exposure function to a core network emulator from Radisys. But this core network emulator has been enhanced with some 3GPP standardized exposed services and interfaces that tie into the SCEF. So what we're able to do is we're able to verify that our OneMPower platform can do things like tell the mobile core network when the device should be sleeping and receive notifications when the devices are awake. So the main takeaway here is that when testing, we need to consider things like how the server checks that a device is even available before we allow that application level interaction to happen. Thank you.
Okay, excellent. Great. Now we have Vikram Sexina from NetScout. Vikram.
Yes, thank you, Kelly. Thank you, everyone, and glad to be here. I'm in the office of the CTO in NetScout, and my focus is on what we do in the area of IoT and virtualization. And what I'm going to talk about today is more in terms of how we give visibility to IoT applications, and from that, how we provide analytics to provide actionable insights. Next slide, Kelly. Okay, so quickly, what's NetScout's business focus? We have been in the space of service assurance, cybersecurity, visibility, and analytics for over 3 decades. We provide a suite of software solutions that capture and transform terabytes of real-time network traffic data into high-value, actionable information that allows customers to optimize the network, manage applications, manage security, and also gain insight into end users. We primarily work with some of the largest operators, both wireless, fixed, and cable in this space, and our solutions are deployed in many of these networks that provide broadband services, mobile services, voice IMS, video, and so on, and more recently, IoT. Next slide, Kelly. So when we look at IoT for us, it represents a fairly complex value chain. If you look at starting at the bottom from devices, which include machines and sensors, to providing connectivity, whether it's at the network layer or the process of onboarding these devices, and then moving up to the data layer where we provide the data aggregation and instrumentation and data aggregation from different points in the network, and then providing value on top of that in in terms of business intelligence, where we provide assurance and analytics, both from a real-time perspective as well as historical trend perspective. And at the top level are managed services and system integration type functions. So different entities in the industry play in these different ecosystems. And when we work with our operators, we are trying to provide assurance across different aspects of this value chain, all the way from devices to services. Next slide, Kelly. So when we look at a typical operator network, basically where an operator is trying to sit is in between the industry verticals, which is shown on the extreme left, and then the different networks and endpoints, whether it's mobile, residential, or industrial, which connect through a variety of different standards and alliances. So, for instance, Zigbee, Z-Wave, IEEE 802.15.4. If you're on the mobile side, it's NB-IoT or EMTC, or industry alliances like All Scene Alliance, which recently merged with OCF. All of these capabilities are then interacting with the service provider cloud, where the service provider provides policy and rules, service assurance, security mitigation, and business analytics. And then these capabilities are exposed to different industry verticals through a set of APIs, which could be from the family of web services like REST and JSON and XMPP or Kafka. And the main value proposition from a service provider point of view is to allow these individual silos to work together to deliver complete solutions. Today's IoT world, as we see, is not well integrated and interoperable because different silos, different devices work within their own silos, and these applications can only talk to devices within their own silos. But where an operator wants to provide value is to make sure that, you know, a device on a mobile network can interoperate with a device in a home or in a industrial setting. And this is where the real value of IoT can be unlocked. And from a NetScout perspective, we sit in the operator cloud and in the networks, and we can measure and monitor these messages as they're going back and forth and allow an operator to look at metrics like throughput and latency, and also whether timely actions are being taken from different points in time. The value to the application providers is they can look at their application holistically and get a business analytics view from how their applications are being used by different service providers or by different end users, and also across different networks. Next slide, Kelly. So from a visibility point of view, we think that most of the core network elements are going to be virtualized in this architecture, and we provide a suite of options for providing visibility, whether it's through a virtual agent that sits along with the application, whether it's a virtual probe technology that sits on the vSwitch and hypervisor, or in some cases, an active agent where we are not able to reach some of these devices directly through our own agent. We can actually test remotely through an active agent technology and verify performance and service availability. So all of these options are available from NetScout so that you can provide complete visibility and instrumentation within your cloud and core network. And the last slide, please. So from an analytics point of view, we provide a couple of different things. We have what we call a real-time analytics engine, which we take the IoT data on the fly, and we provide metadata and real-time insights for data and value that is perishable, which has only real-time value. Then we also capture this metadata in a database and then provide offline analytics for historical insight. And the four key things that we provide in terms of actionable intelligence is, one is descriptive, that shows what really happened; diagnostic, which shows why certain things are happening in the network and what might be the root cause; and then predictive, which is using machine learning techniques to talk about what may happen in the network; and finally, prescriptive, where we describe actions that could be potentially taken. So this is a complete suite of analytics package that we provide for IoT services. With that, I will end and turn it over to you, Kelly.
Okay. Great. Well, thank you so much to all of our presenters. And now we're going to move on to questions. I would like to start out, I think we had a wide range of viewpoints here, and all the way from the RF end of the equation all the way back to the question of visibility and analytics from a network level. I'd like to ask each of our panelists to talk a little bit about what they think of, what do they see as the major current challenges for IoT testing from their own unique perspectives. So let's see, George, why don't we jump back to you and have you talk about that one?
I guess in a nutshell, I guess as speaking from a certification testing organization, I would have to say that the challenges, to the extent that security needs to be part of the design and functional considerations of the product. So it starts out at the inception as it's far more difficult and costly for the developer, and ultimately, depending on if that shows up in the hands of an enterprise, is to be able to go ahead and build, as opposed to building them in retroactively, and or trying to be able to build security around those type of things. And by its nature, the interconnectivity of these will create new challenges for the developers and the service providers, as the security of the quote unquote thing ultimately is only part of what needs to be able to be considered, because ultimately these things get deployed as part of an overall ecosystem. So it's the device, and as was further explained, that ultimately gets into back-end systems and servers for a variety of things.
Okay, Mariano, your thoughts on current major challenges for IoT testing?
Sure, Kelly. I think this question was very well addressed by George and Brad at the beginning, but yes, I agree. First, I believe it's security testing. When we look at the new IoT devices, there will be followed by several new security issues. Protocols are not necessarily answering the requirement for security. Increasing complexity is expected with interoperability, electromagnetic interference, several protocols, and several types of interoperability. Therefore, threat assessment will be a key area to focus on, related to design and coding practices. And of course, increasing compliance certifications measurements are required. Secondly, we see there is a need for better power management, energy consumption, battery lifetime, processing power for IoT devices. The lack of power analysis today undermines opportunities to improve battery life and power consumption related to memory in IoT devices. Therefore, several actions we believe are required to focus on ensuring a constant voltage for a device operating mode and guaranteeing acceptable measurement bandwidth for the sample rate. Evaluating, for example, the power consumption from intricate waveforms, conducting systematic energy analysis, and separating the device design matters from power source problems. And of course, there's a huge proliferation of wireless sources across several industries. Many standards are available and offered for IoT devices. Globally, and as I pointed out at the beginning, the 2.4 gigahertz spectrum frequency bound is too crowded today and adopted for low-cost devices with problems upholding communication in this frequency. Therefore, the capability to easily upgrade models of new standards and support all multiple standards simultaneously with a single instrument is becoming very, very important.
Okay, great. Mike, I want to jump to you and talk a little bit about your thoughts on this question in terms of, and again, this major current challenges.
Yeah, I agree with the previous two speakers that security is a key issue. Just to add to that, I think another issue would be standards fragmentation. Mm-hmm. And what I mean by that is, if I have an industrial control system, a fleet management system, maybe an inventory control system, all leveraging some kind of IoT applications, how do I integrate them and make them all play together? especially if they're using different protocols to communicate, whether it's at the physical layer or at the application layer.
Okay, great. Vikram, did you have any thoughts on current challenges for IoT related, testing? I know that when you and I had our conversation, I thought it was very interesting that, no matter how much testing people do ahead of time, there are still issues that will not be caught until these things are live and deployed in the network. And so, the visibility to see where problems are, is really important for devices that may have varying levels of certification.
Yes, Kelly, yeah. I think that's a very important point. I think, the range and variety of devices that we're going to encounter in IoT is much higher than what we have dealt with so far. It's not like a handful of smartphones that we know how to deal with today, but this variety is going to be increasingly large and complex, and it's be very difficult to pre-validate or pre-test. So I think it's going to be extremely important how we deal with this in a real live network, because issues will come up that nobody can foresee or understand before time. So it's very important to have the right visibility where we can capture misconfiguration issues or timing issues or latency issues that might come up because of device behaviors and network behaviors and behaviors in the cloud. And all of these things, they compound each other and they make the problem of visibility and service assurance fairly complex. And I think we are still in very early stages of this market, so we are still learning. And I think one of the main challenges, as somebody mentioned before, on interoperability, and I also talked about how to make these devices and applications work across silos and be able to assure this not only within the protocols, but also all the way up to the application layer is going to be a pretty significant challenge, I think, as we go down the path.
Okay. Brad Robbins of Lightpoint, your thoughts on major current challenges for IoT testing?
Thank you, Kelly. I think that, one, the problems are all solvable. And the future.
Oh, that's good.
I do think that the key things around, IoT just must work, right? In order to be this magic that connects the world and creates productivity and enhances life, it's got to be secure, it's got to interoperate, it's got to deal with interference. Those are all real world things, but the solutions are out there. I think the key challenge is how do people move rapidly to, take advantage of the opportunity. And that's going to come from working with people who can offer kind of canned solutions to the various problems.
Okay. We did have a question from our audience that who asked, which companies are mostly involved in testing for IoT? Are these major wireless carriers or companies such as Google, et cetera? And I can tell you from the wide range of companies that I talked to for this report, it's everybody from industrial design firms who may or may not have much experience in wireless, but run into the fact that they need to have a device certified at the various levels of certification that are required for wireless devices, all the way up to the test companies themselves being asked to help and consult and as well as the wireless carriers, obviously, requiring certification, carrier acceptance testing, for devices. I don't know if any of our panelists, can speak to, companies, types of companies that they've worked with who are doing the bulk of this, of IoT related testing. I think it probably depends on whether you're talking device, application, or network level testing.
Hey, Kelly, this is George.
Yep.
So I think you described it pretty well, and that from a traditional wireless perspective, a carrier or a service provider, there's certain, not to be able to misuse the word protocols, but certain protocols that are in place in order to be able to go ahead and onboard technology as part of those carriers or service providers. And those fit into different types of certifications, and there can be a myriad of those, based on the individual device and what is implemented. And some of those do have some standards around them. And then at the other end, folks like ourselves, ICSA Labs, that focus on the privacy and security testing of these things, and a lot of the focus traditionally on a lot of service providers and carriers, and I'm saying this generically, is the ability to be able to onboard technology without necessarily breaking things, and to be able to make sure that they interoperate with the conventions that they have in place.
Okay. Anybody else want to weigh in on that one? Okay. Well, let's move on. We did have, let's see. Let's ask about, strategies for overall, for reducing the overall cost of testing. Do we have our panelists? Brad, I don't know if you want to, talk to that. I know that when you and I had our conversation regarding the special report, you mentioned just, speed of testing and the ability to test in parallel, is one factor.
Yeah, okay. So I get asked this question all the time. How can you possibly afford test for IoT because it's going to be so cheap? And the other side of that is, how can you possibly afford not to test? It's going to be mission critical, and you're going to build a brand name on it.
Yeah.
I think the key is to figure out a solution that provides both. And what LightPoint focuses on, and I think has proven successful for many of our customers, is to do fully extensive testing on the RF interface, but to do it extremely quickly, and to do it on multiple devices in parallel to achieve the economic goals.
Okay. I want to ask, what role, I think that's really what things come down to is, ultimately IoT, as you said, Brad, has to work, whether that's network interactions, applications, or the device itself and the RF. But, I think sometimes, people think about usability and whatnot, and, and the application really plays not just a role in sort of the user experience, but also, has impacts on battery life, on the weight of these things on the network. Mike, do you want to weigh in on that?
Yeah, sure. So what came to mind as you were speaking there was a lot of the lower layer protocols today. So whether it be 802.16.4, 3GPP, whatever, they're all offering enhanced sleep modes, right? So where the device can go into some deep power saving state, right? Now, that's great. That'll help us save a lot of power. But if the application is not aware of it or not leveraging it properly, what you'll see is a bad user experience, right? So what I mean by that is, if you have some application and the lower level device is sleeping, well, then you're going to see a bad response time, right? Or if the application isn't properly configuring when the device is going into deep sleep modes, what you'll see is at the other end, at the server end, the server might be trying to send some information to the end device, and you might find that the device is sleeping. So really a complete solution, it needs to make sure that, from top to bottom, we're all playing nicely together.
Okay. Vikram, would you like to weigh in on that as well?
Yeah, absolutely. I think you made a very good point. I think when you talk about application testing, Kelly, it's really what we are talking about is end-to-end. How the devices, the network, and the applications all interact with each other, and that creates complex issues from a service assurance point of view as well as user experience point of view. And, we get involved, in making sure that, the protocols and the network and the application sitting in the cloud all work in sync the right way. And if there are any issues like what was mentioned before, in terms of, sleep mode and chatty applications and bad user experience, we are able to catch that. But to do that, I think you have to go monitor not just the protocols at the lower layers, but also APIs, interactions at the application layer that are taking place. So you need that visibility at all the layers of the stack to be able to provide a true end-to-end view of applications, devices, and the network.
Okay. Great. Well, we're coming up on the end of our session here. I want to give each of our panelists a chance to answer the this question, and that is, what would your advice be to companies who are looking to develop for or deploy IoT technologies? There's a lot to handle here, but I'd like each of you to give that a shot. Mariano, maybe we can start with you.
Sure, Kelly. So as everybody was pointing out, most IoT devices are tested at the protocol layer. We have seen a number of leading companies are focused, for example, on Bluetooth and Wi-Fi protocol test. And leading companies have started to focus on providing a comprehensive final RF verification test before assembly and before products are packaged and tested with access to RF signal control and chipset analysis interface. So repeatable testing with a direct connection to RF signal is needed to really lower cost and accelerate time to market as part of the manufacturing test process. During design validation, we believe it is important to change test parameters and understand the device behavior under different conditions. Equipment that allows this type of testing needs to be configured easily and automated at this stage. The deployment scenario, when we see the deployment scenario is changing with increasing need for test devices in the field and common platform for analysis. New products for IoT, therefore, are becoming, the need for testing becoming more modular platform for field deployment, manufacturing and R&D with increasing requirement for functional test and compliance.
Okay, great. George, would you like to weigh in? What's your advice?
I'll keep this pretty short. So some of it plays back into some of the question a little bit earlier that you had asked, and one of which is sometimes saving money and doing things quickly. It starts with spending a little bit more money. And, part of that, as was just, discussed by this gentleman, is that the diligence that is applied, at the outset of the project, doing a proper level of risk analysis on the design all the way down through and including, for security purposes, proper coding practices, QA, subjecting yourself to external testing, whether or not it's standards-based or whether or not it's third-party testing and certification for security, ultimately reaps a lot more benefit. The consequences, and part of the question is not only developed deployment, et cetera, et cetera. Mm-hmm. As we know today, and I guess everybody needs to be able to put cost into perspective, because costs come in the raw form of, I have to develop this, I have to test this, or you can pay the piper later. So either brand damage or fines and penalties or, legal considerations. And, when you start calculating that into what the real cost is, it ends up paling in comparison.
Okay, great. Let's see. Vikram, why don't we jump to you next?
Oh, sure. Yeah, I think my advice is simple. I think before people start building IoT networks, make sure that from the beginning, you give attention to how are you going to measure, how are you going to instrument, what layers are you going to measure, and how do you assure service on an end-to-end basis. So I think that's key, because once you put up the service, the rest of the time you're going to be making sure it's working as you want. It's if you run into a problem, you should know how to troubleshoot it. So the more attention you give to design at the beginning, the less headaches you'll have down the road, because you'll have all the instrumentation in place to be able to measure and validate and troubleshoot your problems.
Okay. Brad, your thoughts?
Thanks, Kelly. I think what I'd suggest is anybody getting into IoT is going to become a systems company, no longer focused on whatever core strengths they had in the past. And when you're a systems company, you should look for help. And there are people out there who can.
Okay, great. And then we have Mike. Mike, your thoughts on advice to companies looking to get into IoT?
Sure. So a big part of IoT for me is getting the most out of your data, the most value out of your data. So I would advise using standards-based solutions. So what I mean by that is if today you're just thinking about putting a window sensor somewhere, and keep in mind that that piece of data, that small piece of data that tells you if your window's open or closed, not only could it be used for a security reason, it could also be used in the future maybe to integrate with your smart meter, so you can control your air conditioning level based on whether or not your windows are open. So if you don't start off from the beginning using a standards-based solution, you'll never be able to share data across industry verticals in the future.
Okay, great. Well, thank you all. Thank you all. Thank you so much to our panelists. Thank you to our audience. And thank you everyone for joining us today.